So this talk is about giving you a short update about what we are doing to improve the security of Checkmk. Yeah, for us as a monitoring product company, it's important to deliver good performance in good performance here, obviously, but also good security. So and this talk is about showing you something that we're doing. And we talk about improving the product security, so the things that are built into the product. And also, we want to highlight some things we are doing within the organization, within the tribe, to improve our security capabilities. So let's have a look at what we are doing in the product. We are working on adding login capabilities, so to provide more options for you to do user authentication. And we also work on improving existing things regarding the login system, the authentication system, improving the security in this area. And then we are also working on the transport encryption. Checkmk is doing a lot of network communication between the agent and the Checkmk side, but also between the Checkmk sides, if you have distributed environments. Andy had a talk about the agent transport, which we are finally securing now with TLS, and we have some other things we were adding with this version regarding the transport encryption. Then we have been working on the security of the password store. And also, we have been working on improving the so-called software composition analyzers. So far the overview, and now let's have a look more specifically into the topics. So the first thing was somehow triggered also by the input we received on the conference. It is about one of the two highest voted security features you voted for on the recent conference. It's the two-factor authentication. And second thing is the SAML authentication. I will talk about that in a minute. So the first feature addition we made here is adding two-factor authentication to Checkmk to secure the login of your user authentications with the user interface of Checkmk. And we added that capability based on the WebAuthn standard. So you can use some kind of security token, like the YubiKey, to add a second factor to your user authentication. In Checkmk, we are still using the password you define for your user account as first factor, and then once you have authenticated based on your password, then you can use the security token to confirm your authentication. So that's some nitty-gritty thing I want to add for the ones of you who are trying that for the first time. There are some pitfalls when using the WebAuthn in browsers. So it's only working if you're accessing the user interface with the host name or a DNS name. If you open the user interface with an IP address, that will not work. And that's not prevented by us, but the standard or the implementation of the standard in the browser. And that's also true for the protocol you use. If you use HTTP without the S, then this standard will not work. So you have to secure your web interface using TLS first to make use of that feature. And once you have both in place, you can log in to the user interface as usual, then open up the user profile page, your personal one, and then you can click on Enable two-factor authentication. Then you have to have your token at hand to register the token with Checkmk. And after doing that, it is good to also create the fallback tokens. So you can create like 10 unique secrets that you need to store somewhere in your password store safe or somewhere else to have a fallback in case you lose your hardware token so that you can still access Checkmk. So if you have done that, you can log out the user interface and then log in again, and you should see something like this dialog showing up confirming your token. So the second thing I wanted to highlight is that Checkmk is now enabling you to integrate the user interface of Checkmk into your SAML authentication. That's widely used in enterprise environments to make it easier for users to log into web applications. So you have some kind of single sign-on. And yeah, Checkmk is now able to provide this login option based on an how-to, which is linked here, which is very much been created, as Jan highlighted before, by community work, working with members of the community who have expertise in this field, can provide the testing systems and so on. So that's already well tested and might be a good solution for your enterprise environment to provide a comfortable login system. Then about the transport encryption, the user logging improvements. One thing we did is that we improved the security of the user passwords you have stored in Checkmk. So if you save your personal login password to Checkmk, that's now encrypted with bcrypt, which is state-of-the-art hashing algorithm to storing passwords. And it replaces the existing algorithm we used, but everything you have in place still works. So you don't need to change your passwords or reconfirm that or something else. If you create new passwords in Checkmk from the 2.1, create new users, or you change your password, then you will automatically use this improved hashing algorithm. The second smaller thing is that we are now logging login failures in a more detailed ways. So you can see in the application log, the var log web.log of the user interface, whenever a user tries to log in and fails. You see the reason, for example, the password was wrong or the user account was locked, for example. You can also see how many tries the user was doing now, so you can easier analyze what is happening with this user failing logging in. Okay, now the transport. We had the agent-to-site encryption, and now we're coming to the last channel we've had in Checkmk for a longer time that was unencrypted, and it was when using the notification spooler, which is a part of the Enterprise Edition. It's a component which is responsible for forwarding notifications in distributed environments between sites. So if you have one remote site which raises some alert, then you may send out a mail right from that site. But in some environments, you will want to have a centralized notification system, configuration, and so on, sending the mails out there, for example. So the notification spooler comes here in handy to distribute the remote, the alert from the remote site to the central site. Then the notification rules are applied to it, and based on the rules you have there, for example, a mail is sent out to your mail server and reaching the user this way. So we are exchanging notification contents between sites. And the task here was to find a way to encrypt that channel and to do it in a way where it is easy for you to transition to the encrypted channel. So you should experience a seamless update. You update from Checkmk 2 to 2.1, and then you want to start and everything works as before. And then it needs to be an easy way to get the encryption. And this is what we basically solved. We made use of the S-tunnel socket wrapping tool, which is able to encrypt network communication channels without the application to know about this encryption. So it's a wrapper around the notification spooler sockets. Yeah, from a network connection standpoint, the challenge was that the notification spooler allows you to set up network connections in both directions. So depending on your network setup, it may be easier for you to make the connection from the central side to the remote side, or in other scenarios, it might be easier for you to set up the connection from the other way around. Depends on network scenarios, firewalls, and so on. So yeah, to establish a TLS connection between both, we need to have trust in both directions, from the remote side to the central side and vice versa. So in the one direction, from the central side to the remote side, we already have the trust in most cases, in the common cases, because the user interface is already doing TLS with the remote live status. So we can reuse this trust. And the other way around, we didn't have a trust so far, but we were able to build that easily and also transparent for you. You don't have to worry about that because the trust is automatically established by the configuration synchronization. So the central side already has the ability to send information, configuration to the remote side, and in this process, the trust is established. So the remote side is also trusting the central side. So then we are now again with our update scenario, which should be somehow seamless, and we are doing it like this. Once you update, everything is as before. So you have the unencrypted transport channel, and there are some places, the analyzed configuration, for example, which warn you about that fact that you still have the unencrypted communication channel configured, and you would easily be able to move to a TLS encrypted channel. So what you need to do now is to ensure that both of your sites are updated to the 2.1. And once you have done that, you can go to the global settings and notification spooler settings, and then simply do the switch to the encrypted communication, activate it, and then you're basically done. So that's a very smooth, easy transition for you. You just need to ensure that both sites use the 2.1 or newer. Okay, that's for the notification spooler. Let's talk about the password store. The password store in Checkmk is basically a mechanism for centralizing secrets in your configuration. The Checkmk configuration are hundreds of files, potentially, of host names, IP addresses, and so on, and rules in different folders. And everywhere there, if you won't use the password store, there could be secrets in every of these files. So the idea of the password store is to move all the secrets in a central place, in a central file, where you can now manage it easier, where you can set restrictive permissions and so on. But the password store has never been about trying to hide or encrypt these passwords. Because we as a monitoring system, we continuously need these secrets. We need to monitor remote systems, for example, a MySQL database or whatever, which expects us to authenticate. So we need to provide a user and a password or security tokens, whatever, to contact the system and get the actual monitoring data out of the system. And this is needed every minute if you have a minute check interval. So we continuously need the secret in clear text form to authenticate. So that's in memory. Then you expect from a monitoring system that you make a cold boot and the monitoring comes up and runs and does its monitoring job. So to have that, you need to have the secrets stored on disk, somehow accessible to Checkmk in the end in clear text. So we really need these secrets to do our job, to our monitoring job on disk. And in the past, we were always approaching this by simply keeping all these secrets in its clearest form in text files to make it crystal clear that it is needed, that it is done this way. We didn't want to obfuscate or hide or something like that, to make it easy to understand for everyone. So another view to this can be that it's better to obfuscate it at least somehow to mitigate very primitive attack vectors, like people grabbing around in the file system and so on. And yeah, that's what we basically did. Yeah? We are now obfuscating the password store. So on the disk, there is the password store, and Checkmk has access to these information, but if you open the password store in the editor, it's simply some cryptic characters and so on, so you won't be able to grab that as easy as it was before. But since Checkmk is able to access the data, so you will be. So if you have access to the context of the site, the file system of the site, that's similar as before. Just a little bit more knowledge needed to get the information. Okay, so having that said, on the password store, we are also doing other things. From the past, we have several password input fields in the setup where the password store can currently not be used, and we are filling this gap over time to be able, to enable you to use the password store in more places. And for new things we build, we are still adding the password store capabilities by default. Okay, that's about the password store now. And then we come to the next topic, the software composition analysis. That sounds cool, and in fact it is. I mean, I think you all were in trouble in December last year, thinking about Log4j and where it could be hidden in your infrastructure and so on. And this topic is essentially about this, to getting knowledge in what is in your infrastructure, hidden down in your infrastructure in some software you get from somewhere on the planet and so on. And modern software is simply built like this. And it's okay, but you need to know what is inside a product you get. And with Checkmk, we were doing these things for quite some time, mostly for open source license compliance reasons. So we were partially manually creating lists of libraries and tools which are inside Checkmk, which version they have, and so on. But in the meantime, the industry has evolved to some kind of standard, a good thing to do, and that's software composition analysis. You build some kind of so-called software bill of materials, which is basically a data file, an XML file, where you list all the libraries, the versions, and so on in a file. It's a standardized format. You can produce by hand or auto-generated. We are doing that auto-generated for Checkmk. And then you can use tools for analyzing the information in these files. You can compare the list with databases of known security issues, with your own databases or provided by providers with open source databases which are out there. And then you can make sense out of it for your own and check whether or not in the Checkmk versions you use there are security issues inside. So we're doing that for our own. So we have a continuously running process for monitoring these things, checking out which issues come up over time in the versions we have delivered, and then decide what to do. If we need to patch some version or add some hotfix on our own, and so on. And that's automatically done during every software release we make. And the file we generate for a software during packaging, that is also shipped with Checkmk. So in every site, you can open that file and work with it. So, and that's about the in-product things I wanted to show you. And now about the organizational changes we make, the improvements we make. is team-wise. In the development team, we are building up a dedicated security team now of 3 people. We will be 3 in mid of May. And I think it's best if you have such a team to build somehow integrated with the feature teams. So you have the chance to get to know each other. You have the chance to see early in the development life cycle what is happening. You can, as a security specialist, participate in designing the software, the features we build, the changes we make. You can raise your hand if you have concerns regarding security and so on. So that's the way we want to do it. And also, in case of security issues are found, our security developers are not the ones only finding and then complaining about the issues, but they are also part of the solution. So they participate in finding quick fixes for quick fix releases, for hotfix releases, and they also do the job in helping to find architectural solutions for issues, so that we can prevent for the future that similar issues are happening in Checkmk. So that's team-wise. Then we are extending our work with external support. Currently, we are doing security audits twice per year, and that's being done on the software itself, on different scopes, depending on what we want to have checked more in detail, but also on the organization and internal IT, we do these things. And in April, we were doing some kind of pre-audit of for the ISO 20001 thingy. So that's also something we are moving towards, to learn what it is about and what we need to do and improve to move in this direction. And process-wise, we are working on improving and also extending with the help of the security developers, for example, on our processes. So we have a more specified, stricter, tighter, better security processes like incident response processes. And also we are working on educating the team basically to let developers know, let the team know on what to look, what to care for during development. We are, for example, from time to time doing hack the box sessions where we try together in a team of some people to hack some actual sandbox system to raise the awareness of security issues. So during these sessions, you can, as a developer, you can have another view on the problem, on the IT, on the systems you build, and get to know the situation of the attacker, for example, and what he might try to get into the system and so on. Yeah, and I think that's it, what I wanted to share with you for now in this talk. And now, we have hopefully some time left.